It's not just about writing programs, it's all about writing efficient programs. The solution I might improvise here might take probably 10 seconds. Someone else could improvise a solution that takes just probably 5 seconds. Which of the solutions will you rather go for? I guess you should go for the one that takes lesser time instead of... Hello guys, it has absolutely been a while since I posted a content. That's because I have sincerely been overwhelmed by exercises that wouldn't even let me have time for myself. But today it seems like I am less busy. So usually when I'm less busy like this, I usually will just go through my archive and try to retrieve probably any technical or algorithmic problem just to keep myself busy. So today is not an exception. I've pulled out one algorithmic problem from my archive and I want to solve it. But I feel it's going to be beneficial to solve it on camera so that people like you currently watching this video can also learn and benefit from it as well. So right away, I'm going to share my screen and let's see what this problem actually looks like. So you should be able to see my screen now. This is a problem that contains a list of numerical numbers. And the question says, write the functions that print all pairs of numbers in the list that add up to the sum. Example, we have 5 and 3. Summing up these two numbers gives you 8. And we have to write this function such that the two pairs of numbers that would be returned wouldn't be a repetition of the same number, such as 4 and 4, which is a repetition. So it should be two different distinct numbers. When you sum them together, the resulting value should be 8. So if we look at this very list of numbers, we find out that when you sum 5 and 3 together, you have 8. So we have to write a function that will now return all the pairs of two values. When you sum them, the result will be 8. So right now, I'm going to start up my VS Code. I will prefer using VS Code for this solution we want to improvise. So the problem is I don't even know which programming language to use. I actually wouldn't like to use PHP. I don't really want to utilize any scripting language. I feel maybe we should utilize Java. But before then, let me quickly check. Okay, I think I got Python. Let's see. Oops, Python 3 then. So Python 3, excellent. So I have Python. So I think we're going to use Python for this solution we want to improvise. Let's create a Python file. Usually with your VS Code, we want to save a Python file. So we just come to the new file and we say technical. Let's zoom this out a little bit. Solution, technical solution.py. Absolutely Python, right? So I'm going to save this on my desktop. So if I should use the inbuilt VS Code terminal, new terminal, and I should say cd into my desktop because I want to access the desktop directory. So if I list now, I should see technical solution.py, which is the file I just created. I want to copy the algorithmic problem, so I just want to copy this, right? Alright, so I just downloaded the file from my archive and I just want to copy problem. Take it to our VS Code and here we're just pasting it here. I just want to hash it just like you usually comment with Python. Okay, so let's get started. So first thing first, I really want to declare a function, and in Python usually we declare a function using the def keyword, and I'm going to name my function number pairs like this, number pairs. I'm just thinking of the first of all, our function will receive two parameters. So the first one is going to be our lists of numerical arrays, and the second one is going to be the resulting summation value, which is going to be sum. So by default, I'm going to keep sum as 8. So right away, I'm not really bothered about checking for edge cases. All I want is to get a solution that works. It's normal. We are definitely going to iterate through the list of numeric values. But there is something very important that we should be able to learn after our solution has been improvised. It's not just about writing programs. It's all about writing efficient programs. Talking about efficiency, we're talking about programs that take lesser time to solve problem and utilizes little resources or little storage spaces. Not writing a program that will take a long time to solve a problem and then consuming a lot of memory or space on your machine. So the challenge is the solution I might improvise here might take probably 10 seconds to execute and solve the problem. Someone else could improvise a solution that takes just probably 5 seconds to solve the same problem. Which of the solutions will you rather go for? I guess you should go for the one that take lesser time to solve the problem instead of going after a solution that take more time to solve problems. So usually this is the problem we have when it comes to the complexity of algorithm. I will talk about that in a moment. But first of all, let's get a working solution. So first I'm going to walk through the lists of numerical values passed to this function by using a for loop. So I'm just going to say for val in lists. So the individual values in this particular list are actually what this particular val variable is holding. So now I want to use another for loop. That's where the problem comes in. We'll talk about complexities in a moment. So I'm just going to utilize another for loop, and here I'm going to say val2. Okay, here let's call this val1 like this. This one I'm going to say val2 in lists. And this time around, we're going to do a comparison by saying if val1 plus val2 is equal to 8, because we want to actually check for values that when summed together will give us the resulting value of 8. So if the summation of these two values gives us 8, then I really want to do something. So what am I going to do? Permit me to declare another variable here. I'm going to say pairs, a variable with array value. So this is going to serve as a container where we are going to push all pairs that passes our check, right? And our check is value 1, value 2 summed together gives us 8. Once this passes the check, we push this directly to the pairs container. So here I'm going to say pairs.append. That's actually a Python function that pushes some set of value into an array. So I'm going to say push a pair of val1 comma val2, and then finally I'm going to come down here and let's try calling this function by saying number pairs. We're going to pass our lists, but where is our list variable? Not yet defined. So I'm going to define another variable called list, and I'm just going to copy this. We are assigning this array to this variable, and we're passing this same variable to this function. I might directly want to just say print like this. Alright, so now that we are printing whatsoever this function is going to be returning, we need to specify what our function here is going to return. So we're going to return the pairs, rather, like this. So if I should run this script, remember I saved this file in my desktop, and currently I've navigated to my desktop directory. If I list out, I should see we have technical solutions.py. So I'm just going to say Python 3. I'm using Python 3 on my machine, and then the name of the file, technical solutions.py. And if we actually it looks like our script is not returning anything. I don't think I really saved my work, so I'm just going to come to file and say save. Let's try it out again. Python3.py. Oops, we have a syntax error, and what's happening? See syntax expected column. Excellent. So because this is a block, and then we have to specify our column. So let's try this out again. Oops, we're still getting the same error. Am I really saving at all? I just saved my work. Let's try it again. Excellent. So you can see that we now return all the pairs of numbers when summed together give us the resulting value of 8. 7 plus 1, 8, 6 plus 2, 8, 5 plus 3, 8. But we still have a problem because remember the question was saying without repeating, sorry, this is a spelling error, without repeating same numbers. Here we have repetition, so we just have to improvise a conditional check that would get rid of that. So I'm just going to say if val1 is absolutely equal to val2, what we just want to do is to say continue. This is going to skip this particular iteration and proceed with the next iteration. So with this we are good to go, and if I should run the script again, I didn't save, so I just have to save my work. So if I should run the script again, we have a syntax error. So what I will do is the check will be if val1 equal to val2. What we want to do is to say continue. So I'm going to save my work and try this again. I'm just going to clear python3.py again. Excellent. So now we have all the pairs of numbers when summed together gives you 8 without repeating any numbers in a given pair twice. So, but there's a problem with this solution. That's where complexities of algorithm comes into play. So if you look at our list, we only have, I think, just 9 numbers in this particular list. So the length of this list is 9, absolutely. I just want to represent length of lists with the symbol n. So now that n is 9, you can imagine what happens when n turns to, let's say, 1000, right? Then there is a problem, because this line of code will walk through this list n times. So if the numbers in this list continues to increase, that implies our loop is going to walk through the items in this list until it gets to the end of the list. So if we have 1000 values in this list, our iteration will walk through this list 1000 times. That is really going to take a lot of time, where you even have numbers ranging millions and billions in a list. Now the problem is, we are not iterating just once, we are iterating twice. You see here we are iterating to get val1, and here we are also iterating to get val2. It's really a complex algorithm. Permit me to show you something when it comes to algorithm, because we really want to optimize this solution to get a better and more efficient performance. Let's quickly understand what measuring the complexities of algorithms look like. I want you to understand that the complexities of algorithms are measured on 3 basic cases. So we usually would have the worst case scenario, that is the worst thing that will ever happen in your solution. We also have the best case scenario, the best thing that can ever happen in a particular solution you've improvised, and also the average case. And by the way, when talking about complexities, I'm talking about the amount of time it will take for your solution to solve a problem, or the amount of space, resources your computer would utilize in order to solve a problem. The worst case is usually represented with a symbol called the big O, usually with the symbol O and the worst case. So similarly, we also have the big omega with the symbol usually used to represent the best case. And then we also have the big theta with the symbol and then average case, right? So when measuring complexities, we usually pay less attention to these 2 guys, that is the best case and the average case. We usually pay less attention to these 2 guys. Where we are more interested in is the worst case. You should always think of the worst thing that will ever happen. So back to my second screen, I'm just going to create another file, new text file. I want to put this side by side. I will save this file, call it worstcase.txt. I'm still going to save it on my desktop. I just want to pull the file on a separate window. Move this window one side, pull this other one to the other side. Excellent. So we'll have it side by side like this. Let's minimize command line. And now, remember I said the worst case is what we are really concerned about when measuring complexities of our algorithms or our solutions we've improvised. I want to list out some basic worst case scenario symbols. There are specific symbols we use to represent worst case scenario, and I really want to list them on the order of their complexities. So the complexity continues to grow as the list continues. Remember, we are dealing with the big O notation, the symbol of the worst case. So it's going to be the big O of 1. And what this symbol particularly represents is what we call the constant time or space. By space, actually, I'm trying to talk about the memory space on your machine. So remember, measuring complexity is measuring the amount of time it will take, or the amount of space that is required for a solution to solve a problem efficiently. So the next complex one is the big O notation. Remember, we're dealing with the worst case. If I were talking about the best case or the average case, I wouldn't be using the big O. I would rather be using the theta symbol or the omega symbol. So the next complexity would usually be the log of n. And this symbol usually is referring to the logarithmic time or space. The next complexity would be n, like this. A symbol representing the linear time or space. The next complexity, the n, log of n, right? Which is a combination of the log n by n. right? So that gives us the n log n, and this symbol is usually representing what we call the linear rhythmic time or space. The next complexity is the n square, n raised to the power of 2, and this is a symbol that represents the complexity called quadratic time or space. The next more severe complexity has a symbol of big O of n cubed, n raised to the power of 3, and this symbol is usually called the cubic time or space. So the next complexity is usually the big O notation of 2 raised to the power of n, and this is usually the exponential time or space complexity. I think we also have another complexity, the big O notation of n factorial. So this is called the factorial time or space complexity. So basically, I've just outlined symbols that can be used to measure the worst case complexity of an algorithm. So see you guys next time. Subscribe to the channel and turn on the notification bell, as we would always attend to problems like this, especially those finding their way to the tech industry. Peace out.